Hello, my name is Chris Hill, and I'm a researcher at the University of Colorado Boulder Craft Tech Lab and the Atlas Institute. The title of our paper that I'm presenting today is the ThreadBoard, Designing an E-Textile Rapid Prototyping Board. Our paper is about the development of a novel prototyping board designed specifically for E-Textiles called the ThreadBoard. In the paper, we discuss our design process, design considerations, features of a magnet-based design, and the ThreadBoard as part of the larger E-Textile tool ecosystem. E-Textiles is a field of embedded computing that enables creators to design and build textile computational devices. The stitching of conductive thread traces allows for the freeform design of pathways that connects microcontrollers and other components. This is a powerful distinction from traditional circuit boards and breadboards, which impose a more rigid, grid-like design for conductive connections. Our research identifies a key technique of traditional embedded computing that is missing from E-Textile creation. This technique is the rapid prototyping of threaded circuitry during the initial design stages. Our solution to this problem is to develop an E-Textile tool that allows for the placement of freeform circuitry, uses materials and components that are native to E-Textiles, does not stifle creativity, is non-intimidating to novices, and can be made at home. So current E-Textile tools for rapid prototyping can be arranged on a spectrum from highly structured to open systems. On the highly structured end of the spectrum, the user is typically given proprietary components that fit within a pre-designed form. By constraining choice, the structured kits help the maker avoid errors, but restricts the creative freedom that, on the other end of the spectrum, open-ended kits afford. While open-ended kits offer more creative and design freedom, they can also be more challenging to assemble and allow for bugs that the user wouldn't encounter in a structured system. We believe that E-Textile makers need a tool that provides enough structure so they can quickly prototype their circuits, but without restricting the variety of circuit designs they can create. The ThreadBoard addresses this need by providing a rapid prototyping board that uses components native to E-Textiles and that allows free placement of conductive thread, sensors, actuators, and microcontrollers. The need for rapid prototyping tools for E-Textiles is also highlighted by the difficulties associated with debugging threaded circuitry. Upon finding that their project does not perform as intended, E-Textile makers face the often disheartening task of disassembling their project to isolate and identify bugs. Once they find a bug and attempt to fix, the maker must then restitch portions of their project in order to test it. This trial and error approach is time-intensive and frustrating with the regular stitching and restitching of circuits. While some tools have been suggested to assist with locating errors in E-Textile circuits, either during or after the sewing process, we instead advocate for students to iterate over their circuit design before sewing, in a manner similar to the traditional solderless breadboard, where the user can quickly disconnect and reconfigure hardware components and a microcontroller. This is an early prototype of the ThreadBoard that served as a proof of concept that we can embed magnets into pre-existing microcontrollers easily, and that they would allow for an intuitive connection with the magnets embedded into stiff felt. The main issue with this design was the layout restrictions. The ThreadBoard could only support one or two actuators or sensors, and also due to the layout design, the user could not easily utilize all the adjacent pins available on the microbit. This is the current version of the ThreadBoard. This version was inspired by the initial user tests and insights gained from the previous iteration. The layout was inspired by the circular design of E-Textile microcontrollers like the LilyPad Arduino and Adafruit Circuit Playground. This design allows for the creation of more complex circuitry as well as the implementation of microcontrollers and E-Textile components. This is the ThreadBoard toolkit we've been developing. Due to the metals used in certain components like the vibration motor, LEDs, and stainless steel thread that you see in the picture, these components are attracted to the magnets embedded in the ThreadBoard. We also discovered that you can enrich pre-existing microcontrollers with magnets to have them interface with the board as well. In this video, we can see an example project called the Big Dipper, where several LEDs and stainless steel thread attach to the microcontroller to make the circuitry. In the video, you can see me populate the board with 7 LEDs and then lay the ground bus on the outer layer of the magnets, and on the inner circle of magnets I lay down the power bus. Then I connect the LEDs to the buses to power them on. For future work, we are currently distributing ThreadBoards to students in the wearables class for both feedback on the board designs and to document what types of projects and circuitry students make with the ThreadBoard. We are experimenting with creating a three-dimensional prototyping device, which will more closely take the form of objects like teddy bears or stuffed avocados, for example. Currently, the ThreadBoard encourages radial designs due to its magnet layout being circular. We plan on observing how different configurations of magnet layouts can affect circuit and project designs. In conclusion, the ThreadBoard is a rapid prototyping platform for E-textiles that utilizes a system of magnets. Incorporating magnets provides a prototyping platform that is more appropriate for E-textiles than the solderless breadboard. Makers no longer need to work with single-use snap connections or maneuver alligator clips onto small pins. Rather, they can now lay circuit traces with conductive thread. Moreover, without the opaque top layer substrate of conventional breadboard, users can better visualize circuit connections, allowing them to more easily troubleshoot complex designs. Makers also do not need to fabricate or purchase special components for use with a ThreadBoard, as the magnets simplify modifying commercial electronic components. As a result, the ThreadBoard enables makers to build prototypes with components that can be directly transferred into a final product and have a more authentic e-textile experience. Thank you for listening to our talk. This work would not be possible without the National Science Foundation, as well as our colleagues at CU Boulder. If you follow the link on the bottom of the slide, there are instructions on how to fabricate your very own ThreadBoard. Thank you.